Hello friends, this is video on demand, myself Professor Nalin Thakur. The question is how the converging magnetic field acts like a mirror and find the point in the magnetic field where the charged particle is reflected back. Now what do you mean by converging magnetic field? Converging magnetic field means it can converge the charged particle, it can focus the charged particle in a point at which the value of magnetic field is maximum and particle will be reflected back. Now you see this figure, B is increasing along the z-axis. This is the z-axis, B is increasing means you can see, suppose these are the parallel lines of magnetic field, okay, but this magnetic field is increasing along the z-axis. That means magnetic field becomes dense and very dense along the z-axis. I mean, suppose here magnetic field is 5 Tesla, magnetic field is 10 Tesla, magnetic field 20, magnetic field is 100 Tesla, and so on. Here magnetic field is increasing and increasing like that. Magnetic field is increasing along the z-axis like this. Now this is the velocity v of a charged particle is entering in this type of a increasing magnetic field along the z-axis. V is the velocity of a charged particle and theta is angle of incident. Velocity have two components, V perpendicular and V parallel. Now you know that what is the path followed by the particle? Path followed by the particle in magnetic field is helix or spiral like this. Okay, and we will prove that its radius of gyration or Larmor radius will be decreasing in this type of magnetic field. I mean, B is increasing and Larmor radius will be decreasing and particle will be focused at particular point. We will discuss as follows. Now, how we study about the convergence of a particle or focusing of a particle in magnetic field. You can see magnetic moment of a charged particle can be represented by current multiplied by area. Magnetic moment of a charged particle remaining always constant. It is a constant quantity. What do you mean by current? Current equal to charge divided by time. A is the area, pi RL square. What is RL? RL is called Larmor's radius. I mean radius of a gyration. This one is a radius of a gyration. This one is a radius of a gyration. This one is also a radius of a gyration. This one is a radius of a gyration. So, mu equal to I mean charge divided by time. A is equal to pi RL square. Again, let me say, what is omega? Omega C. Omega C, it is the angular cyclotron frequency of a charged particle moving in magnetic field. Okay, so omega is equal to twice pi F equal to twice pi 1 upon T because F equal to 1 upon T. Clear or not? Okay, so the value of 1 upon T equal to omega divided by twice pi. I mean omega C cyclotron frequency divided by twice pi. So let me write mu equal to E is the charge, omega C is the cyclotron frequency, twice pi RL square. Again let me say, what is value of omega C? Cyclotron frequency can be represented by E B by M. E is the charge, B is the applied magnetic field, M is the mass of the particle. Omega C equal to E B by M. Okay, this is law. Cyclotron frequency can be represented by omega C equal to EB by M. Now again, you see mu constant equal to E square B twice pi M pi cancel, okay, and RL square. But from this equation you can say, in our case, B is continuously increasing in this direction. Okay, mu is constant. Mu, I mean magnetic moment of a charged particle is constant. To maintain mu constant, B is continuously increasing. What should for RL? RL must be decreasing. RL must be decreasing. If this is increasing, that this RL must be decreasing by keeping mu equal to constant. So in this way, to maintain mu constant, B is increasing, RL must be decreasing, and convergence or focusing of a particle is possible. You can see here, you see, B is increasing, RL should be decreasing. That means the radius of gyration must be decreasing. You can see this radius is maximum, this radius becomes minimum, again this radius becomes minimum, this radius has become minimum along the increasing magnetic field. A stage will come, RL will be equal to 0, and particle at this point will be reflected back into the system, and reflection of a particle will become possible. And this value of B, for which reflection of a particle becomes maximum, it is called B max. It is called maximum magnetic field. Particle will be reflected back. So in this way, convergence of a particle or focusing of a particle become possible, and we can say how the converging magnetic field acts like a mirror. How the converging magnetic field acts like a mirror. So this type of increasing magnetic field, for which radius of the particle, radius of the gyrus of the particle, okay, will be decreasing and decreasing and decreasing. So this type of magnetic field is called as a converging magnetic field or focusing magnetic field. Okay, so in this case you can say, what is the value of theta? Sin theta. Sin theta equal to this V perpendicular, this is also V perpendicular. Okay, sin theta equal to V perpendicular divided by V. V perpendicular divided by V. Okay, sin theta, V perpendicular divided by V. You see here. Yes, sorry for that. Okay, V perpendicular divided by V. Sin square theta equal to V perpendicular square V square. MV square, MV perpendicular square. So MV perpendicular square divided by MV square. Sorry for that, it is not V perpendicular, it is a ordinary V like this. I mean total V. Okay, total V total. And this is V perpendicular. Okay, you can see here. This is V total and this is V perpendicular. Okay, so same thing is there like this. MV perpendicular square, MV square. So 1 of MV square, 1 of MV square. So kinetic energy perpendicular divided by kinetic energy total. 1/2 MV square equal to kinetic energy total. So what is kinetic energy perpendicular? Can be represented by mu times B. W perpendicular can be represented by mu times B plus this value. Okay, divided by WT, total kinetic energy. So you can see here this equation, sin square theta divided by B equal to mu divided by W total. This is a constant quantity. This is also a constant quantity. So this ratio is constant. This ratio is constant. That means sin square theta 1 B1 equal to sin square theta 2 B2 equal to sin square theta 3 B3 equal to constant. So that means we can write here sin square theta divided by equal to sin square theta 0 divided by B0. What is theta 0 and what is B0? We can say at initial time t equal to 0. Okay, we can say initial value of magnetic field is B0 and initial angle of incident is theta 0. Okay, now you know that for theta equal to 90, for theta equal to 90, sin 90 equal to 1, sin 90 equal to 1, and value of this will become B maximum. Value of magnetic field becomes B maximum, and at this value, okay, particle will get reflected back. Particle will get reflected back. You can see B tends to B max is the value of magnetic field at which particle will be reflected back. This value is equal to 1. B equal to B max. So B0 divided by sin square theta 0. At this point, converging magnetic field acts like a mirror. Converging magnetic field acts like a mirror like this. Okay. So we can see here sin square theta 0, B0 divided by B max in denominator. So theta 0 equal to sin inverse square root of B0 divided by B max. This is theta 0 angle of incident. So theta is greater than theta 0 for this value. It is called trap cone. It is called trap cone. Particle will be trapped inside the magnetic field. For theta is less than theta 0, this is theta 0. So in this case, theta is greater than theta 0, okay, particle will be lost in a magnetic field. So in this way, we can say that, okay, in converging magnetic field acts like a mirror. Converging magnetic field of a charged particle will be acts like a mirror like this. Thank you very much.